Today I've got Vinit Chaudhary. He is the founder and CEO of Elemental Composites. They specialize in the production of nonwoven mats, and they create non-woven fabrics with consistent and uniform fiber distribution. Their process stands out for its versatility, allowing for the incorporation of diverse reinforced fibers such as carbon fiber, glass fiber, and natural fibers. And we're going to be talking about that. Vinit is a graduate. He graduated from UT Knoxville, got his undergraduate and his master's. But Vinit, thanks for spending some time on the podcast today.
Thank you, Jonathan. Thanks for having me. Happy to be here.
Yeah,
thanks for inviting me.
Yeah, absolutely. I know we didn't get a chance to talk at the Innovation South back in February. I know you were there in attendance, but why don't you start with your background as a student and what kind of led you to start this company?
Yeah, no, thank you. So I think it's kind of an exciting journey for me. So I did my undergraduate in mechanical engineering at University of Tennessee, graduated in 2020, and it was a COVID time. I had different plans, but then I had to rethink my strategy for moving forward. So I had a job in hand after I graduated, and then I was also talking to a lot of people about whether I should go for graduate school or get a job. I had a job in offer for a field engineer in a wind energy sector. So then I talked to Dr. Udavidya, with whom I already worked while I was an undergraduate student. He was very supportive for most of all the students in his lab. So then I talked to him. Then he kind of guided me, but then he gave me an opportunity to continue with my master's degree at Fiber and Composites lab. So I got on board with that. Then one of the project which he pitched was I was continuing with that in my undergraduate days during summer, and then he provided me an opportunity to continue working on that. So I liked that. One exciting thing which I liked on that was the path to commercialization when he presented. So I come from a family of entrepreneurs, and I always wanted to be an entrepreneur myself.
Yeah.
So I got excited as soon as I saw that commercialization opportunity, and I was like, hey, let's do some research.
Sure.
Get to work and see where it leads to. So yeah, my thesis work mostly was based on developing nonwovens for recycled carbon fiber. So when I graduated, and during graduate school as well, we traveled to different conferences, and we got good traction on our research. Where at a conferences in SP and SEMPI, we won first and second prize for our research work. So that was a team effort, and we were very confident that this technology can be commercialized in future. So once I graduated in 2022 December, I thought of applying for different programs here locally. So we were like, hey, how can we gauge the viability or the scalability of this technology, whether someone wants it in this marketplace or not? So then we were part of a regional I-Core NSF program here at University of Tennessee, where we conducted 20 plus customer interviews, learned more on business model. So that was a first learning experience in business side of this, where we talked with industry leaders, where they provided some feedback on our technology and where it can be used and how it can be used in different applications. So we were pretty confident that I think it's a good way to move forward, and we can scale this up. So during graduate program, Dr. Vaidya filed an invention disclosure here at University of Knoxville UTRF office, which is commercialization office. Then later, through this invention disclosure, we filed provisional application, and right now this technology is currently patent pending. So with that experience of customer discovery, we applied for the very first time. As soon as I graduated, I applied for Innovation Crossroads program, which is a fellowship program here at Oak Ridge National Lab, which is funded by DOE. In March of 2023, I remember we made it all the way to finals, but we were not selected as one of the company for that cohort. So with that experience, we were like, hey, we can learn more on the business side of it. I know engineering, coming from an engineering background, with no business experience in the tech space, we thought of doing an accelerator program. So we have a great accelerator program here at UT Research Park called
Right.
Spark Clean Tech Accelerator. It's a 3 month or a 12-week program where they teach you on commercialization, prototyping development, business models, financial modeling, and all sort of stuff with a great team of mentors, experts, industry leaders. So we were selected as one of the 6 companies to be part of that program. And then as soon as we graduated, I again applied for Innovation Crossroads in 2023, November.
Yeah.
And then finally in May, I think we heard back from them that we are in the program. So,
Awesome.
so that's a quite a journey, and I think
Yeah, I'm sure.
without the support of, I first and foremost, it's Dr. Vaidya. Without him, I don't think we would have been able to make it so far like this. And
Yeah.
now there's so much in Knoxville ecosystem for in general for business, entrepreneurship, and composites. That's
Yeah. What are some of the things locally that you've been able to tap into in the Knoxville area?
So I came to Knoxville region in 2015, and that's
Yeah.
when I came to United States. But
Hmm.
and then I joined UT in 2017, and at that point, there was we were not hearing this word entrepreneurship or like startup businesses and things like that. So I think in 2017 or somewhere around that time, Innovation Crossroads was a new program which was started by Tom Rogers.
Hmm.
And then slowly UT Research Park got incubated. And so there were over the years there were so many programs related to startups, supporting startup companies
Yeah.
to provide them mentorship, to provide them funding opportunities. So my entrepreneurship journey kind of started back in undergraduate days. There is something called Wall Court here at
Hmm.
University of Tennessee where you go, you learn about business, and then you finally pitch about your business idea. So mine was something related in retail space, but that's where I started my enthusiasm about entrepreneurship. But
Yeah.
there are several programs now. There are so many programs here in Knoxville region. We have a thing called KEC, which is Knoxville Entrepreneurship
Yep.
Center. We have the
Yep.
Works Accelerator. We have UT Research Park, Spark Clean Tech Accelerator. Now we have Innovation Crossroads kind of program. So there is so much going on. Like any founder, if they have to start a business, they can literally get help right away with
Yeah.
all the mentors and funding opportunities and guidance from already the people who have been through this process.
Not to mention, you said you come from a background of entrepreneurs, right? I mean, you said you've got entrepreneurs in your family.
Yes, so
Yeah.
it's my
It's
my
great.
parents, like they have businesses in retail industry, so that's why
Sure.
I grew up in that household
Absolutely.
where yeah, so that helps a lot too.
That's great. Let's spend some time and talk about kind of the uniqueness of these non-woven mats. I know you've got a presentation pulled up here that we can take a look at because a lot of these are with bio-based fibers, right?
Right. Yes. So initially we started with I think recycled carbon fiber and glass fiber, but then quickly what we realized was after talking to so many industry leaders and conferences that that industry non-woven space is already saturated. There, I don't think like there has to be any innovation done in carbon fiber or
Mhm.
glass fiber space in terms of non-woven. So we thought of pivoting to, let's say, why don't we focus on natural fibers? So when we started learning about natural fiber, and when you compare with European market, which is much more developed in natural fiber composite space, but here in United States, when you see that's not the case.
Right.
So we dive deeper into that, and then what we realized that um, like there are a bunch of natural fibers, like for example coconut fibers, banana fibers, flax fibers, hemp
Hmm.
fibers we are working with. They are great, but they have a lot of limitations, such as moisture absorption. They don't go really well with moistures.
Yeah.
They have low strength by itself. Like you cannot use these fibers alone for composites application.
Sure.
They have poor adhesion to resin. Like if you see the work on glass fiber and carbon fiber, there has been a lot of different sizing have been developed. But on natural fibers, it's none or very limited research we have when it comes to sizing chemistries.
Yeah.
So as a part of our solution, like we have a two-step unique manufacturing process.
Hmm.
So we use non-contact acoustic mixing where we are able to mix different types of fibers. So for example, let's say you have to mix flex fibers with polypropylene or different nanomaterials. So you can mix your fibers with different functional uh, materials. So you can coat your fibers, you can mix different types of fibers. And
Hmm.
what does that is after mixing, you get a homogeneous mixture of fiber stock, which goes into our dry lead manufacturing unit. So just by the nature of our manufacturing unit, we get kind of like anisotropic non-woven material at the end. So here we are trying to like the three problems which I mentioned earlier in natural fiber. So with our manufacturing technique, it's completely dry laid. So there is no interaction between natural fibers and moisture. So we are eliminating that issue. Low mechanical performance, so we can functionalize this natural fibers with structural fibers or other nanomaterials to boost their mechanical properties. And also the poor resin adhesion issue, we are able to create unique sizing for this natural fibers to be able to like have better bonding with thermoplastics and
Hmm.
thermoset materials.
Yeah.
So yeah, that's the unique part of our manufacturing, and that's our technology in short.
Which of the natural fibers have you had the most success across a number of spectrums? I mean, I hear a lot about flax, which
Right.
is, being adopted more and more. I mean, but from your perspective, which has been the most successful?
Yeah, you're right. Like if in research has shown that flex is comparable to glass fiber.
Hmm.
Flex. So if you talk about United States supply chain, flex is very limited. Like all of the flex comes from Europe.
Yeah.
Now we have seen is there is a lot of industrial hemp being grown here locally. So we are trying to double down on hemp fiber, but
Yeah.
also coconut fiber. Our supply chain is from India, and also banana fibers. Banana fibers are very good with vibrational and acoustic properties. Based on our initial testing and data we have generated, it's without like a lot of different chemistries, but purely just from mechanical testing perspective, we have seen flex has given better result, flex and hemp. Versus if you talk about banana fibers, they are better at insulation and thermal
Hmm.
properties, acoustical
Sure.
properties. But yeah, it's an ongoing work which we are trying to functionalize most of this natural fibers with nanomaterials and sizing chemistries.
Yeah.
So then we can truly know the potential of these fibers for different composite applications.
So let's talk about some of the applications specifically for automotive. I was reading your materials unlock a number of applications for the non-woven mats, and these can be tailgates, seat backs, roofs.
Right. So initially, when we started doing all this customer discovery and stuff like that, we thought about doing automotive. But then quickly, what we realized was, yeah, a lot of this natural fibers can be used in automotive interior and
Yeah.
even exterior parts.
Right.
But it's a very tough industry to get into, and a lot of rules and regulations. So then we started focusing on industries like transportation and built environment, like infrastructure. The engagements we had on the transportation side, for example, the customer had issues with the purely they were using wood as their trailer decking application, for example.
Sure.
So there was an issue of contracting during summers and winters, like expansion and contraction. So they were having a lot of warranty recalls. But then when we proposed our composite trailer decking application with our coir fiber nonwoven, which we have made some prototype and paneling, so they were interested in that solution of composite trailer decking. So we are targeting applications such as for transportation sector like trailer decking, trailer walls.
Yeah.
In the infrastructure side, we are targeting applications such as cladding panels with hemp fibers, for example, and also insulation material, which can provide vibrational or sound acoustic properties. Also on the sporting goods, we made some prototypes on pickleball and ping pong paddles, where it can
Oh
be
yeah.
used as a top and bottom layer. It's the fastest growing sports on the planet,
Yeah.
so why not? um,
Yeah.
and a lot of sporting goods are finding natural fibers.
Yeah.
Natural fibers are finding their way into sporting goods application. Some of them has to be aesthetic appeal. Some of them has to be like biodegradability or low carbon footprint. Some of them, like a lot of these non-wovens, can be literally can be formed into complex shapes
Yeah.
because it's discontinuous versus continuous fiber. So that's what this non-wovens with discontinuous fibers and natural fibers can do.
So let's talk about the fiber length, because existing non-woven manufacturing techniques are limited to a fiber length of 25 millimeters, if I'm not mistaken, whereas your manufacturing approach allows for longer fibers. Is that right?
Yes, yeah, that's exactly right. So if you see in non-woven manufacturing, there are mainly three manufacturing methods out there: uh, wet laid, which is paper making; air laid; and then dry laid, which is carded non-wovens. So the manufacturing technique which we are using is dry laid or carded non-wovens, which so the uniqueness in that is like we can go all the way up to 1500 GSM, which is areal density or areal weight of the fabric. So 1500 grams per square meter. So anywhere from 15 to 1500, versus the other manufacturing techniques are limited to, let's say, maybe 300 or maximum of 500 GSM of areal weight. We can with the in terms of fiber length, composite properties are driven by fiber length. So a lot of this other manufacturing non-woven techniques, they are limited to 25 millimeter or less, which is 1 inch or less fiber length. Versus with our manufacturing technique, we can go up to right now the ideal would be 3 to 4 inches of fiber length, but we can also go up to all the way to 10 inches of fiber length. So higher the fiber length, better the mechanical properties. Again, depends on manufacturing type,
Sure.
what kind of fibers you are using, and things like that.
Yeah.
And from natural fiber perspective, I think dry lead manufacturing makes sense because you're not dealing with water, you're not dealing with moisture issues. You are able to
Right.
dry lead them and be able to more functionalize them to make it more uniform.
Mhm.
So that's the uniqueness with our manufacturing technique when you're compared with other non-woven manufacturing technique, which has great applications in different fields. With our, we unlock different applications as well.
Vinit, it's been a pleasure, man, having you on. I wish we had more time. Quickly, how can people learn more about you? I know you guys are working, you're in the process working on a new website coming up, but in the meantime, what's the best way that anyone who's listening can connect with you?
Yeah,
I know you're on
so
LinkedIn, so we'll be posting on LinkedIn. So that's one area.
right, people can find me on LinkedIn. Currently, my email ID is vinit at theelementalcomposites.com. Stay tuned for next 2 weeks. We'll be launching our website, which is theelementalcomposites.com, and here is my contact info. So yeah, please, anyone
Fantastic.
who find this useful, feel free to reach out to me directly.
Well, let's stay connected. Let me know when that's up, and we'll actually add that onto the show page, and we'll be sharing it on all of our social media channels. Vineek, I look forward to staying in touch with you. Thanks again for joining me on the podcast
Yeah,
today.
it's been a pleasure, Jonathan. Thank you so much for having me. You have a good
Yep.
day.